Edwards Air Force Base, California, 1955. A control tower operator raises a set of binoculars. Something is about to happen that no one on this base has heard before. Miles away on the lakebed, ground crews are told to cover their ears. Not because of an explosion, because of an engine. This is the Republic XF-84. Some called it a fighter. Most called it something else. The loudest aircraft ever built. Its propeller tips broke the sound barrier before the aircraft even left the ground. Every startup became a continuous sonic boom. Ground crews reported nausea, headaches. One engineer reportedly suffered a seizure just from standing near the aircraft while it idled. It was meant to give jets the range and efficiency of propellers. Instead, it became one of the most feared test aircraft in Air Force history. This is the story of the Thunderscreech, a machine built to solve one problem and undone by the very technology meant to save it. By the early 1950s, jet fighters had transformed aerial combat. But at sea, they created a new and dangerous problem. Early jets accelerated slowly. If a carrier pilot botched an approach and needed to go around, the engine simply couldn't respond fast enough. Propeller aircraft didn't have that problem. Their engines responded instantly. But propellers couldn't match jet speed. The US Navy wanted the impossible, an aircraft with jet-level speed, but the throttle response, range, and low landing speed on a propeller plane. No catapult required. No compromise on performance. The Navy turned to American industry for a solution, and one company was ready to gamble. Republic Aviation had already built its name on rugged fighters, the P-47 Thunderbolt of World War II, and the jet-powered F-84 Thunderjets that followed it. Republic's answer to the Navy's challenge would come from an unlikely evolution. The swept-wing F-84F Thunderstreak, reimagined with an engine no fighter had ever carried. Inside Republic's engineering division, the project received a designation, Project 330 Thor. At its heart would be a turboprop, an engine that spun a propeller using jet turbine power. But this propeller would spin faster than sound. The aircraft was initially designated the XF-106. Later, to tie it more closely to Republic's existing fighter line, it became the XF-84. 3 prototypes were planned. But partway through development, the Navy withdrew its support, unconvinced the concept could ever be made safe for carrier use. The US Air Force stepped in instead. Through the Wright Air Development Center's propeller laboratory at Wright-Patterson Air Force Base, Ohio. The program's purpose shifted. It was no longer a fighter for the fleet. It was now a research aircraft built to answer one question. Could a supersonic propeller actually work? Only 2 aircraft would ultimately be built. Serial numbers 51-1755 and 51-7060. Neither would ever see combat. Both would make history for very different reasons. The XF-84 used the airframe of the F-84F Thunderstreak, but almost everything ahead of the cockpit was entirely new. Its power came from an Allison XT40, a 1 turboprop engine, mounted behind the cockpit and connected to the nose propeller by a long extension shaft. That shaft had to spin the propeller fast enough to reach supersonic tip speeds, something no aircraft had ever attempted before. The propeller itself was roughly 12 feet across with thin, square-tipped blades designed to punch through the sound barrier on every single rotation. When those blade tips exceeded the speed of sound, they didn't just make noise. They generated a continuous, overlapping sonic boom. Engineers projected a top speed of Mach 118, making the XF-84 the only turboprop aircraft in history ever fitted with an afterburner. The design also introduced something no aircraft had carried before, a retractable ram air turbine, ready to swing into the airstream and provide emergency power if the engine failed. Given how often the Allison engine would struggle, that backup system would prove far more necessary than anyone at Republic wanted to admit. On paper, the XF-84 was brilliant. In the workshop, it was becoming one of the most mechanically fragile aircraft the Air Force had ever commissioned. Before it ever flew, the XF-84 had to be started. That alone became an event no one at Edwards Air Force Base would forget. Because of the noise, the aircraft was towed miles from the flight line before its engine was ever switched on. On July 22, 1955, Republic test pilot Hank Baird climbed into the cockpit for the X-84's first flight. The engine roared to life, and the sound rolled across the desert like continuous thunder. Ground crews miles away could still hear it clearly. The aircraft climbed away from the lakebed. For a brief moment, it seemed the concept might actually work. But almost immediately, pilots reported violent vibration through the airframe, along with unpredictable pitching and yawing that made the aircraft difficult to control. Past roughly 400–500 miles per hour, the shaking grew severe enough that pilots described losing confidence in the aircraft entirely. Of the first prototype's 11 test flights, the majority ended not in a normal landing, but in a forced landing back onto the lakebed. The Allison engine itself was unreliable, prone to failures that forced pilots to rely on that emergency ram air turbine again and again. On the ground, the noise was becoming its own crisis. The propeller's continuous sonic booms were reportedly audible more than 20 miles away. Ground crews near the aircraft during engine runs reported nausea, headaches, and disorientation. One engineer was reported to have suffered a seizure. Eventually, the control tower at Edwards asked Republic's crews to tow the aircraft several miles further out before even starting its engine. Republic test pilot Lynn Hendricks, who had flown some of the company's most demanding aircraft, reportedly told Republic he would never fly the Thunderscreech again. The second prototype, 51-1760, fared no better. It flew only a handful of times before the entire flight test program ground to a halt. Across both aircraft, the X-84F flew a combined total of only 12 test flights between 1955 and 1956. And yet, in that brief and troubled flight test career, the aircraft still reached an unofficial top speed of around 520 miles per hour. That speed made it, unofficially, the fastest propeller-driven aircraft ever flown, a record that would stand for more than 3 decades. Despite that record, the XF-84 never came close to operational service. It was never intended to. By this point, it existed purely as a research aircraft. No production order was ever placed. No squadron ever received one. The instability and mechanical failures made that outcome impossible to justify. By September and October of 1956, the Air Force made its decision. The program was formally terminated. The XF-84H's last flight took place on October 9, 1956. The supersonic propeller experiment was over. Both prototypes were retired. One would eventually be preserved. The other would not survive. For years afterward, the surviving aircraft served as a static display, a gate guardian at an Air Force base, its true story fading from memory. In the 1990s, restoration specialists brought the aircraft back to its original condition. Today, it sits inside the National Museum of the United States Air Force. It's easy to call the Thunderscreech a failure, but every flight generated data that engineers couldn't have gathered any other way. The program proved, decisively, that propeller tips could not be pushed past the sound barrier without unacceptable noise, vibration, and instability. That lesson quietly shaped decades of propulsion research, steering engineers away from raw propeller speed and towards smarter aerodynamic solutions. Modern turboprop aircraft still use propellers today, but their tip speeds are deliberately kept well below the speed of sound for exactly this reason. The Thunderscreech's real legacy isn't the aircraft itself, it's the boundary it drew, a line engineers have respected ever since. The Republic XF-84 was never going to be a great fighter. It was never meant to be. It was a question asked at full throttle, and the answer it gave, however loud, however uncomfortable, helped define the limits every aircraft designer since has had to respect. Today, visitors walk past the Thunderscreech without hearing a sound. But for 2 years in the mid-1950s, it was one of the loudest things ever built by human hands. It never fired a shot. It never flew a mission. But it earned its place in aviation history all the same. The Republic XF-84H Thunderscreech, built to be fast, remembered for being loud, and never, ever